Hey, AVLI BC Calculus. This is Mr. Alger here, and I'm going to go over this document that goes over everything that you need to know for Trig, like in really short form. So we know there's going to be a few things that I leave out because we're trying to do a very quick review at the beginning of the year, and anything we've left out, we hope to pick up later on. You should have gone through that the entrance quiz, the tryout quiz to say, well, where am I with the trig stuff? And some of those questions will be worked into this. And let's go to it. And I'm just going to power through. It might take 2 videos. We'll see how it goes. So everything you should know about trig abridged. So the first thing is you should just have a really good conception of the basic definitions on a unit circle. So that's a circle of radius 1. And you should have the basic idea of what sine, cosine, and tangent represent. So for sine, then sine is going to be the y value because it's the length of this y y segment. Technically, it's the coordinates of the point on the unit circle. That way it can be positive or negative. Cosine is the x. And tangent is the slope because it's y over x. Let me put all those things down so you have them here. Filled all those in. So the sine is the y of this point. The cosine is the x of that point. The tangent is the slope of this terminal ray, this segment that you have right there. If you have those concepts really solidly and you always go back to them, they'll answer a lot of questions you run into in other places, and we'll see that. You should also know all your reciprocal relationships or other rationals. So tangent you can define in terms of sine and cosine, cotangent also, and then all 3 of these are reciprocals of other things. Take a second, see if you remember what is a reciprocal of what. I'll fill it in just a moment. Pause. Filled all of those things in, and you should know these rational ones, the ones that are fractions, and you should know what's the reciprocal of what. So let me know if you have any questions on those. And then the next part we get is to trig values. And looking ahead, it was these questions right here, being able to answer trig value questions without a calculator or a cheat sheet or anything like that, reasonably quickly, reasonably accurately. You'd want to be able to do that because you don't want to do this long calculus problem, and at the end it asks you what the cosine of 2 pi over 3 is, and you have no idea, because that would be a drag, like if that impedes your ability to show your calculus knowledge later on in the year. So and so we just got to go through the fundamentals of that. So first, for these nice values of pi over 6, which is 30 degrees, pi over 4, pi over 3, and pi over 2, and 0, you should know the sine, cosine, and tangent just kind of off the top of your head. Keep in mind one thing, notice one thing here is that we're dealing with radians. Calculus is so much easier in radians. So whenever we can, we'll go to radians. That's why I haven't bothered to put degrees in my little chart. They were in the doc that I took this from, but for the little graph, but not in the chart because there's no point in dealing with degrees in this class. So you should know this really quickly. Now, if you think about this idea of sine being the y value, then it becomes a lot easier to know which one is which. Like what is the y value? Get off my head. What is the y value when you're sitting right here on the x-axis? Well, the y value is 0. So you go, oh, okay, that'd be 0. And then as it rotates up, as this point goes up and gets bigger and bigger and bigger and moves up the thing, then the y value gets bigger and bigger and bigger. And based on that, you can fill in those values. It's 1/2. Ooh, I'm moving a little bit. That happens sometimes in tables. When you make a table, sometimes I do not know why surfaces do that, but they do. Root 2 over 2, root 3 over 2, whew, and 1. So 0, 1/2, root 2 over 2, root 3 over 2, 1. Gets bigger and bigger, bigger as you go. So cosine is just the same idea, but it's the x value, and you can fill those in. And then tangent is the slope. So if you think about it, tangent's going to start, let me make sure I'm on here we go. Tangent's going to start at 0, and then the slope is going to get bigger and bigger and bigger as you go, right? And it's just the slope of that line as this line is getting bigger and bigger and bigger and bigger. As the slope is getting bigger, as the angle is getting bigger. Okay, take a second, see if you can fill those in, or if you know what those things are. I'll pause it, and then I'll fill them in to save a little time. Filled in all the values. Cosine does the same exact values. It's just going from here to here. It gets smaller because the x value is getting smaller. Cosine's the x value. So it starts at 1, and it goes down to 0, but it's doing the exact same values. And finally, you've got tangent. Tangent is getting bigger and bigger. I don't know. When I first started teaching, I just memorized root 3 over 3 and root 3 And I knew root 3 over 3 had to be smaller, so that would be the one that was small, and root 3 is bigger, so that's the big one. And 45 degrees has a slope of 1, I knew that. And a vertical line has an undefined slope, so I knew that one too. So you'd want to know these values. Maybe you memorize it as a chart, or maybe you just think of that bigger, bigger, smaller, smaller kind of idea. And either one gets you those values so that you can work them out. The other thing you need to know is you need to know what's positive and what's negative. And the cool thing about that understanding of what is sine, cosine, what do sine, cosine, and tangent represent, is that tells you when things are positive, when things are negative. Sine is positive when the y is positive, because that's what sine is. And so it's positive up here, and it's negative down there. Right? That's what y values do. Cosine is the same thing. And tangent is positive when the slope is positive. And so you go, oh, okay, these are positive, but then these are positive here because a line like that has a positive slope. And it's negative in the other two quadrants. The other way, that's the way I usually do it, is I just think of one at a time. But the way some students do it, I'm trying to be flexible because I know you guys have learned pre-cal and algebra trig all over the country. So yeah, you could have been taught it in all or countries, excuse me. And so you could have learned it in a bunch of different ways. And so I'm trying to be kind of flexible with how I show it, not saying this is how you must do pre-calculus, because you already learned it and it's silly for me to try to undo that. But some of you may have learned the other way that's really, really common, which is the all students take calculus, or all students, what's the other one? All students take calculus, all students take chess. I mean, you could come up with a bunch of different acronyms, whichever one you want. But this keeps track of what's positive where. So all of them are positive there. Sine is positive there, which means the other ones are negative. Tangent's positive there, and cosine is positive there. And that just fits in with the other ones. Whichever way works for you, great. So that's how you can put it all together. So I'm just going to run through these problems real quickly and show how the stuff we just talked about, if you practice it, helps you know how to do these. Okay, sine. Sine is the y value. Pi over 2 is sticking straight up. The y value up there is 1. Whoa, 1. Cosine. Cosine is cosine's the x value, but ooh, I see it's a 45-degree reference angle. You probably learned reference angles. And so it's 45 degrees off the x-axis. So that's square root 2 over 2. But 5 pi over 4 is down there, so that's negative root 2 over 2. Cosine, negative pi over 2. Ooh, negative goes down, goes this way instead of that way, so that's just pointing straight down. What's the cosine? X value right there, 0. Tangent of pi. Pi is going this way. Oh, can I see? Yeah, there we go. Pi is going that way. Tangent of pi. What's the slope of that line? Because tangent slope, 0. Tangent, negative pi over 6. Ooh, okay, so I'm kind of down like this, so I'm down in this quadrant, so I know my answer is negative, because tangent's negative for lines going down, because it's going down here, and the slope's down. That's pretty flat. That's the small one. That's root 3 over 3. If it was steep, that's the big one. That's root 3, because of the whole slope and smaller slope, bigger slope thing. Cosecant, pi over 3. Cosecant's reciprocal of sine, so I should do sine. So in my mind, I'm saying, what's the sine of pi over 3? Well, I know sine goes, so it's root 3 over 2. That's a big one, but it's the reciprocal of that, so that's 2 root 3 over 3. Secant of pi. Secant's reciprocal of cosine, so I got to do cosine. Cosine of pi, that's negative 1 over there, because that's the x value. The reciprocal of negative 1 is negative 1. Duh. Again, these last two I just threw on as extras. They weren't on the original quiz, but I thought I've got space, so I might as well make a couple extra. Sine 2 pi over 3. All right, 2 pi over 3 is like this. All right, the sign there, it's big, so first it's the y value, so it's positive. I know it's positive. And the y value is big, so it's root 3 over 2. But now what if I was in the same spot and was doing cosine? So now it's the x value, and so now instead it's negative. And the x value over here, it's only a little bit off 0. 0 is here, the x value, right? And so if I move a little bit over, that's the small one, that's 1/2. Now again, you might have learned it a different way. You don't need to be rocket scientists at these things. Like, it's not a critical thing for this class, but you're going to run into it, and it's going to show up in different problems. And so just reviewing that, getting reasonably, like I said, reasonably accurate on these, reasonably in a reasonable amount of time, and you'll be fine. Finally, there's trig identities in order of importance. We're going to make it in one video. So sine squared plus cosine squared. Sine squared x plus cosine squared x. This is one you should just know off the top of your head without thinking about it. You wake up in a dream, and your dog is, you're still dreaming, and your dog is talking to you, and it says, what's sine squared x plus cosine squared x? Even in your dream state, you should still say that it's 1. It's always 1. I think I have time. Really quickly, that just stems from our original drawing. And that's where the basic unit circle idea is so helpful. This is a right triangle. So sine of this squared, that's what sine squared x means, plus cosine squared x has got to be equal to 1 squared, which is 1. And so it's just a Pythagorean theorem just showing up. So it's not a mystery why this is true. Once we have these definitions, it's got to be that way. So back we go. So you also want to know this like in slightly altered forms. Like, you don't want to just know if you see sine squared plus cosine squared, then it's 1. Like, this is an identity. This is always true. So you'd also want to know that, subtracting over, that sine squared x is 1 minus cosine squared x. And cosine squared x is 1 minus sine squared x. So just keep your eyes out. Keep your eye on those, because you'll need to be able to see it in a variety of forms. You might see this, and we want you to recognize and go, oh, Pythagorean identity, sine squared plus cosine squared. That's cosine squared, and work it out. Next, in order of importance, is this one, but it actually follows from something later on. So let's go to that later on. Yeah, we'll do this. So that later on thing is down here. Sine of, and I just use different letters because you got to get used to different letters and not always X and Y's and A's and B's. So I thought K and L, what the heck? And so sine and cosine of each one of these, pretty uncommon, but these would be good ones to know. And so take a second, think, do you know what these two formulas are? I'm going to write them down with it paused. I filled them in. The sine one is pretty basic. It's each, sine and cosine of each, and the sine stays the same. Cosine, the cosines are grouped together and the sines grouped together. And please notice that the sine is the opposite. That's why it's minus plus. So if this is a plus, then this one will be a minus, and vice versa. Okay? So those ones, now if you plug in instead and make each one of them an A, then you get the identity for this one, for sine of 2A. And so when you do that, you end up getting that it's sine A cosine A plus sine A cosine A, which is 2. Oh! He might choke at the finish and not make it. 2 sine A cosine A. So that's what you end up getting. And then we have these 3 different versions here of the same thing, and this is actually what cosine of 2x is. Now, all these switching arounds of x's and k's and a's and l's, I'm just trying to be really flexible on letters because you don't want to be locked into one letter always being there. So this is what the cosine 2x formula is. You do it the same way. You use these formulas to show it. And then if you substitute for like 1 minus sine squared for the cosine squared, that can alter it, or 1 minus cosine squared for the sine squared, you end up getting these different versions. And the reason why I wrote it backwards is just because you want to be able to recognize these identities either direction. So you don't want to just know, oh, if I see sine 2a, I know what to do. If you see this other side, you also want to go, oh, I recognize that. That's sine 2a, and then simplify it. So we got those. Same thing with the cosine, either direction. And finally, this one. This is a tangent squared plus. This is the other Pythagorean identity. And all it is if you take this original one and divide everything by cosine squared, then sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1, and 1 over cosine squared is secant squared x. So this is called a Pythagorean identity because it comes from that Pythagorean theorem one that we have up above, that oh so important one that you'll remember in your dreams, right? But this is just an altered version. And if you divide it a different way, you can get that 1 plus cotangent squared is equal to cosecant squared. That's dividing everything by sine squared. That's the stuff you need to know. Let me know if you have any questions or if I can help in any way. There'll be those practice quizzes, and you want to work on this till you have it down, finished with 5 seconds to spare. Hit that pause button.